class. So very quickly, I'm going to go over the part one, or just the full review for the exam coming up. I actually just took the exam. As long as you study this review, you honestly have nothing to worry about. It is definitely going to help some of you for your average. So let me begin really quickly. For the first question, if this molecule is a blank, it will be attracted to water. So attracted to water and mix with it. So we remember like dissolves like, or like mixes with like. So water is polar. Those of you in my class should definitely know this. Water is polar. So phobic means scares of water. It is not scared. Hydrophilic, yes. Hydrophilic substances dissolve or mix with water. Polar, remember water is polar, yes. And then there's also charges whenever you have water. So that will be it. This one does say there can be more than one correct. So we have B, C, and D. We have all three answer choices. Moving on. If a molecule is blank, it will donate a proton. Those are your keywords. So acids donate protons, and the ones that receive them are called bases, or your base. So this is an acid-base situation. Moving on. If the molecule has both hydrophilic and hydrophobic parts, but the hydrophilic parts are on the outside, will it mix with water? So this, we can say there's a hydrophilic head with a hydrophobic tail. So they start creating structures, and these structures will keep the hydrophobic towards the inside and the hydrophilic towards the outside. So they actually would mix. That hydrophilic barrier would be on the outside. This is something you see mainly in biology. Next one, many reptiles, even desert-dwelling reptiles, have hydrophobic scales on the outside of their body. Why would a desert reptile want a hydrophobic covering? So again, hydro is water, and then there's a fear of water. Why do we want something dealing with being scared of water, right? Repel harmful sun rays. Hydro has to do with water. It does not have to do with sun rays, so we'll just use our process of elimination. To prevent water loss through skin, our keyword is water, hydro. So that may be possible, and to protect from acid rain. Acid rain is not something that we're dealing with, so it would just be B, to prevent water loss through skin. You can just connect one and one. When you're in a desert, you do not want to dehydrate, you do not want to lose your water, so that's why you want hydrophobic scales. Next, researchers often design medicines that can be swallowed, digested, and diffused into the bloodstream. What property do medicines have? Remember, you are 92% water. So if we are going into an organism primarily composed of water, we want to be hydrophilic. We do not want to be scared of water, and non-polar does not mix with water. Again, remember, H2O is polar. So you need medicines that are hydrophilic. They will go through those barriers. They will like water. So that is our first part. Very simple. Moving on. So how many functional groups are there? Identify them and name them. I actually love functional groups. This is something that I worked a lot with in college, organic chemistry. I personally find them very fun. So really quickly, we can identify 1, 2, here's our bigger one, 3. This is the one that sometimes people miss, and this one is down here. So again, when you have your OH and your double bonded oxygen, this is a carboxyl, or your carboxylic acid. Honestly, they normally use carboxylic acid more often. Here, that nitrogen gives it away. This is an amino. So as soon as you see that nitrogen, you should automatically have a little light bulb that tells you this is an amino. When you have that OH and you do not have your double bonded carbon with the oxygen, this one you already know is an alcohol. They do call it hydroxyl, but honestly, alcohol is more commonly used than the hydroxyl group. And then lastly, over here we have our methyl group. This is a hydrocarbon. The next part, you're going to match the different functions. So methyl, because it is a hydrocarbon, we know that this is nonpolar. So methyl is nonpolar because it does not like water. Hydrocarbons do not like water. A carboxyl is also called a carboxylic acid. So this one would be your acid. So we already used nonpolar, we already used our acid. And alcohol. And alcohol has oxygen and hydrogen just like water. So this definitely is polar. It'll hang out with water. And then aminos are basic. So this means that they will accept hydrogens. They want hydrogens donated to them. So that means they are basic. Next, moving on. If a molecule is hydrophobic, again, fear of water, it will repel water. It does not attract water. Phosphorus, they just randomly put it in there, honestly. So you know it repels water. How many hydrogens are present in phenylamino-pyrimidine, PAP? I'm going to assume it's this one up here, phenylamino-pyrimidine. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hydrogens in total. There we go. Here we're going to match the molecular formula with the line drawing. So this first one, I have a CH3, which is a methyl group. So right here, again, as your last video, you should know that these at the end are considered carbons. So here I have 4 carbons, right? I have 4 carbons in total. So I'm going to look very quickly. Actually, I'm sorry. I have 2 carbons, and those are just the bonds to them. So I have a carbon here and a carbon here. This carbon already has 1 bond and this second bond, so it has 2 hydrogen. So I have OH, a carbon with 2 hydrogens. Here I have a carbon with an oxygen double bonded, and this is your O. So this one is actually B. This is structure B, so we can look at it again because I messed up. They did it a little bit differently. So here we have our carbon here. This one's double bonded to an oxygen, and this one's bonded to an OH. So again, carbon can bond 4 times. So we have 1 bond here, 1 bond here. So here I would just need 2 hydrogens, and 1 bond here, 2 bonds here. This one would just be 1 hydrogen. That one looks like B. I am looking for that that methyl group, right? So here I have 1 carbon and I have my other carbon. This carbon is bonded 1, 2, 3 times. So you only have 1 hydrogen there. This carbon is bonded 1, so I have 1, 2, 3, CH3. So if you look at it, you see CH3 carbon with 2 oxygen and your hydrogen. So this one is A. Again, this next part, it is very vocabulary based. We have purification, enzyme, solvent, and antibody. So they attach to foreign bacteria, viruses, and tag them. So this is your antibodies. They are very important, especially now when we're trying to find ways to solve the great mystery that is the virus. Physical separation. So your keyword would be separation from chemical substance, entrance, or contaminating substances. I just think of like the purification of water. You separate those things that you do not want in the water, and they are more pure. Proteins that increase the rate of reaction by lowering the activation energy. So these are catalysts or enzymes. Enzymes is mainly the word used for biology or biochemistry. I know in my class we use our other word. I had it in my head and I completely forgot. Catalyst. There we go. Lastly, the component of a solution that is present in the greatest amount, and it is often water. This is your solvent. Remember, the universal solvent is water. So match the molecular formula to the correct line drawing. So this one is pretty fun. Again, we have to remember, carbon has 4 areas. It can connect 4 times. It wants to bond 4 times. So each dot here, we have 1, 2, 3, 4, 5, 6. Each one here is telling us that we have carbons. So each structure here has 6 carbons. We've already identified that. And my blue one, remember, we want to have 4 lines attached to this. So this one has 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I have C6, H6. This one would be B. Next, I have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So again, this one would be C6, H12. This one is C. And lastly, let's identify this middle one. So I have 1, 2, 3, 4. 1, 2, 3, 4. This one already has 3, so I only want 1. This one also has 3. I only want 1 bond. 1, 2, 3. 1, 2, 3. So 3, 6, 9, 10, 11, 12, 13, 14. Mommy. Those are 4 bonds. Sorry, guys. Yes, baby.
But my dad made a pop sound.
He made a pop sound. I hope he's okay. Baby, I'm recording a lesson. Okay. Mommy's working, okay? Bye. Take brother over there, okay? Because I'm recording. Sorry, guys. The beautiful disruptions of JP and Joaquin. So moving on, guys, we have, yes, so it would have been C6, H14. I'm sorry, guys. The amino acid. So again, you are looking at the word amino and acid. So you are going to need an amino group. Amides we are not working with. An acid, the one that is an acid, is also your carboxylic acid or your carboxyl group. We are not working with carbonos. We are working with carboxyls. Moving on, which of the statement is true in regards to an acid molecule? So remember, acid molecules do not accept, but they donate protons. Helium atoms, I'm thinking that they're trying to connect hydrogen and helium, so that's why they might have thrown that in there, but our answer would be B. We're almost done, guys. So a hypothetical amino acid has a group in its side chain. Which one is not one of its properties? So for this one, what I found, sorry guys, an amino group, not one of it. So if it has an amino group, we have our NH. It is basic. It is going to be charged. It is going to be nonpolar. So the answer, let me double check, guys. I'm just reviewing for the polarity of that one. I cannot off of the top of my head for some reason right now. Yes, so this one would be not one of its properties. It would not be non-polar. Sorry again, guys. Moving on to number 9. A hypothetical amino acid has a methyl group as its R group. Which of the following properties does it have? So again, we want to know what properties a methyl group has. Remember, methyl is a hydrocarbon. Hydrocarbons hate water. So this would be a non-polar substance. Over here, guys, it's just a quick review of something you've already done. So I'll use my old page because I messed up the first time. So we just have to remember collagen provides structure. Hemoglobin maintains proper pH. Proteins have to do with growth, maintenance of tissues, transport of nutrients. Antibodies bolster immune system. Human growth hormones, or HGH, act as messengers. Pepsin, which is in the digestive system, causes biochemical reactions. Albumin balances fluids, so fluid balance, it's right there. And then the breakdown of skeletal muscle, building blocks of proteins. This is provide energies, which is your amino acids. Thank you guys. I hope this helps you review. I know that you will do amazing on the exam. In case I'm not able to host class tomorrow because of a meeting, please contact me if you have any questions at all. Have a great day, guys.